It's the start of the new water year, and we're going to take a look at the state of the climate in California and provide an outlook. This is meteorologist Alex Tardy with the National Weather Service. On this map here depicts the current status of this long-term drought. You can see that central and southern California, most of the region remains in the extreme to exceptional drought of D3 to D4. It's important to note that on this map here, drought depiction includes soil moisture, water supply, groundwater, other impacts associated with drought, more than just snowpack and precipitation deficits. This video presentation will provide you with detailed information on the state of the climate and an outlook for winter 2016 and 17. We've had some significant precipitation recently in October. A storm system across the Pacific tapped into tropical moisture and delivered heavy rainfall across northern California and also the Pacific Northwest, as shown here. Some of the mountain locations received over 10 inches of rain. Most valley and coastal areas received a few inches of rain. Very beneficial rainfall, however, for October. Here we take a look at the water supply across the state of California. On the left-hand side, you can see the blue area is the amount of water or the water capacity, and in most cases it's below the red historical line, for the exception of a couple of the larger reservoirs which are at historical values, such as the Shasta Reservoir. Now we look to the right, that's Southern California, and we can see that even though the reservoirs are smaller, the Diamond Valley Reservoir, which holds just under 1 million acre-feet, is at 69% of capacity. This is up from last year, where it was down to 36% of capacity. Water into this reservoir comes from the Colorado River and also from Northern California. Let's take a look, before we get too far into this presentation, on precipitation that occurred last year, 2015 and 16. Remember, that was an El Niño year. The precipitation, not only was it below normal, as indicated here, between LA and San Diego, where an average of about 11 inches fell, it was one of the driest years on record. You can see a lot more years are piled up around the normal, as you would expect. Now, some of the wettest years, that was 82, 83, 97, 98, those were two big El Niño years. You can see the El Niño average in light blue is also shown. The bottom line is, not only were we below normal, we were way below some of the couple of the prior big El Niño years, or even the El Niño average. What did it look like? On a map of percent of normal, you can see Southern California was in the orange and red. That's less than 50% of an average year, so any given year, let alone that it was El Niño last year. San Diego County did a little bit better thanks to some heavy rains we saw in January. Pacific Northwest was very wet, as shown in the green and blue shaded areas. These are some of our deficits. Now, we did receive some beneficial rain in September in Southern California, but take a look at some of these deficits here. So just last year, as shown in the map prior, most locations received less than 70% of normal precipitation. In fact, Orange County even less. That area is looking at a deficit over the past 5 years of 40 inches of rain. That equates to about 3 full seasons. And you can see it's not just Orange County, it's the mountains, it's also the desert areas that the deficits are very large since the beginning of this drought. What went wrong last year? Well, in 82, 83, 97, 98, a small sample size, but two of our larger El Niño winters. The storm track was pretty much on average, as shown here, moving across the Central Pacific and into Central California. This is not what we call a Pineapple Express, however. This is a Pacific westerly zonal or extended jet stream. Now, last year, we had a similar weather pattern, much stronger than it normally would be, thanks to the El Niño, which I want to remind you through this presentation, El Niño is an oceanic condition. It's a measure of water temperatures in the ocean along the equator, not a measure of the atmosphere or a measure of rainfall. That storm track was prevalent north of Hawaii, and unfortunately, though, it turned to the north, affecting the Pacific Northwest as shown in the earlier slides, and leaving Southern California mostly out of it, except for a few storms in March and January. Here's a look at a basic map of high and low pressure. You can see persistent area of upper level low pressure area was over the central Pacific. A little bit too far to our west to affect us here in Southern California. Of course, whenever you have deep low pressure, you also have high pressure compensating on the other side of it. And you can see upper level ridge, not the same ridge that affects us in the summer across Southern California, but a different ridge that is impacted from lack of thunderstorm activity in the tropics and also the placement of the overall pattern as shown in purple here, just too far to our west and north. Now let's look at the same map but focus on the beginning of the drought. 2011 and 12, that winter, domination of upper level high pressure system, not over land but over the central Pacific, pushing all the storms to the north. As you can see, the storm track in purple is way north. Now, if you look the following year, we actually had a little break in the pattern where storm track was able to squeeze between two upper level areas of high pressure or unusually warm pockets of air in the upper levels of the atmosphere. And that did help Northern California with a few storms. Now let's take a look in the lower left, 2013 and 14. That's when the upper level high pressure area, not the high pressure area that we see over the Four Corners region, but a lack of storms across much of the Pacific, and also what's resulted in some very warm ocean temperatures. This has resulted in the warm ocean temperatures, not the ocean temperatures resulting in this high pressure. That began in 2013 and 14 and really continued all the way through 2014 and 15, blocking most of the storms across the west coast. So it hasn't just been last year, 2015-16, the past several years. This shown here is an accumulation of 36 months or 3 years. You can see the epicenter of the drought and the lack of precipitation is southwestern California, where most of the areas are in that red shading, half of the precipitation they should have normally received. We can also look at it in a time series and compare the last century. Are there any periods with less precipitation with consecutive 36 months? And the answer is not really. The period we've been seeing over the past several years is either the driest or the top 3 driest. We see a dry period of 36 months back in the early 60s and also around 1900. What makes this drought different, however, and this is very important, the past 36 months has been the warmest period on record here in Southern California, and in fact, most of California. We have not seen a period this warm, and it's not just the summers, it's the winters, and that results in stress on the drought, higher snow levels, or quicker snow melt, and these warm temperatures result in elevated fire danger as well. This is about a century of data shown here. Here we'll take a look at the summer or the monsoon season. On the left-hand side, we can see temperatures between June and September, even though they started off really hot in June and July, were near normal for coastal southwest California. However, inland areas continued to be very warm, if not quite a bit above normal, across the mountains and also the desert areas of central and southern California. Now take a look at precipitation. Precipitation typically doesn't occur very widespread in California, but the monsoon typically does bring wet activity to southeastern portions of California, such as the deserts and mountains, and those areas received very little precipitation, such as the San Bernardino Mountains, almost no precipitation. We did receive beneficial tropical rains, if you recall, back in September, which mainly affected parts of Riverside County and western San Diego County, as shown here. Speaking of one of the heat waves, in June, the start of the summer, we had an incredible heat wave. And here are some of the temperatures to take a look at. We saw all-time high temperatures at Borrego Springs of 122. Palm Springs hit 122 and was just shy of their 123 all-time. But it wasn't just the deserts. Take a look at the coastal areas and the inland valleys. 114 at Riverside, Escondido 106. That was an incredible heat wave to start our summer. Well, this lack of precipitation, the very warm temperatures, not just the past year, but the past several years, has really taken a toll. Over the summer and into the early fall, we saw fuel moistures, or the measure of the amount of moisture that's in the dead or live fuel, at near record levels, as shown here in the blue shade. In fact, the Blue Cut fire, which is shown in the upper right, burned rapidly from the start of the fire to about 30,000 acres burned in 24 hours. It was burning in humidity of 1 to 5%, very low values. However, it's important to note it was not burning and did not burn that way in Santa Ana wind conditions. It was normal daytime winds in the mountains of the San Bernardino Mountains, but yet still burned very aggressive and out of control, a reflection of those very dry fuel moistures and the low humidity. We also take a look at soil moisture, as mentioned earlier, for drought depiction. And you can see that most of Southern California, from the mountains all the way down to the deserts and the coastal areas, the soil is showing up very dry. One thing we want to discuss briefly here is the ocean temperatures. And the ocean temperatures were incredibly warm in the month of July. In fact, near record breaking. We had mid to upper 70s for most of July at our California beaches. And the water extended far offshore, even though El Niño was long gone at this time. We saw recent cooling of that water, especially in the month of August, and that continued into September, where ocean temperatures actually went below normal in parts of the Pacific and the Baja region, but just hovering a little bit above normal in the coastal California area of the California Bight. Now, when we take a look back at the bigger picture, the El Niño or La Niña zone that we focus on along the equator, we can see there's also cooling occurring there. But take a look at the very warm water in the northern Pacific. That very warm water is ultimately the reflection of that lack of storms I've been showing you over the past several years. So the ocean temperatures are absorbing the excessive heat from the drought and also the excessive sunshine from the lack of storms. Now, as far as making more storms, that's not going to help us. We still look to the El Niño or La Niña zone in the tropical regions for the most influence on the jet stream or the storm track for our region, not the northern Pacific. And focusing on that El Niño or La Niña zone along the equatorial Pacific Ocean, this time last year, El Niño was at its strongest point, and that was the strongest El Niño on record, tied with 97-98. Keep in mind, when we talk about El Niño, it's an oceanic condition in the tropical Pacific Ocean, not atmosphere and certainly not rainfall. Now, most recently, we've seen some subtle cooling in that area, shifting over to closer to a La Niña phase. One thing we've also noticed with El Niño and La Niña is typically the coastal waters of California follow along with El Niño. But about 2 years ago, when the blob formed, we noticed a separation where very warm waters moved into the west coast well before El Niño developed, as shown here. And then El Niño rapidly fell apart, but yet our ocean water temperatures, as shown in the maps prior, in July, remained very warm. Okay, we've seen a lot of El Niño years and a lot of La Niña years. Last year, like I said, was record-breaking. As you can see here, it held above the 97-98 for a pretty extensive period. Now, La Niña and El Niño, our current conditions are right at that threshold where we're dropping off into La Niña. Our computer projections show the same thing. The expectations are that we will enter into a weak La Niña as we enter into the winter of 2016-17. One thing to keep in mind is some of our biggest rainfall in Southern California is not tied to El Niño or La Niña, not tied. In 93, 91, and 79, those are three examples where we had intense rainfall. But don't forget, we had intense rainfall in a La Niña period. Again, La Niña is the tropical ocean conditions that are below normal, not the atmosphere. In 2010, where San Diego saw 5 inches of rain and widespread flooding in the month of December, most of it coming in about a week during a La Niña. Historically, we've seen across the region a variety of impacts from La Niña and El Niño. A lot of our El Niños are on the wetter side, but there were a handful of them that brought average or even dry conditions. The one year that really stands out is our La Niña, or the cold phase of 2010-11. That was wet, and we had above normal rainfall, thanks to a very wet December. A little refresher of what La Niña is. Well, it's the enhancement of the trade winds along the equator, and this is why it's an equatorial tropical ocean condition and not an atmospheric condition. And those winds get stronger, allowing cold water, or colder than normal water, to come up to the surface, and it pushes all that warm water, such as the warm water we see with El Niño, further to the west, as shown in the red area. Now, typically with La Niña, we have a variety of jet stream patterns, and so we tend to see variable conditions, but we also tend to see, more often than not, the storm track goes across the Pacific Northwest in La Niña. Here's another depiction of what we're discussing. The western part of the United States tends to be separated. Because of the lack of storms, the Southwest tends to be on the drier side and wetter on the Northwest portion of the United States. We can look at the neutral years, which are either those very weak La Niñas or those very weak El Niños, the neutral conditions. And when we average them all together, it tends to be dry across the western part of California. But if you look at the individual numbers, there's quite a variety. Like for San Diego, for example, we've had anywhere from 3 inches of rain to as much as 15 inches of rain when we average 10 during neutral conditions. La Niña conditions, the dry signal shrinks, but it remains across central and southern California. And you can see the distinct wet signal for the Pacific Northwest, at least in the La Niña years. When we break it down month by month, we see a similar evolution of persistent wet or above normal conditions over the Pacific Northwest in our La Niña years. And then we can see California on the drier side. It is interesting to note in some of the La Niña years, we've had very short winters, and that's kind of been the trend over the past 5 or 6 years, where we dry out significantly, such as in February and March, and that can be an impact for fire season. We look at computer models as well, and they kind of indicate the same thing with that slight drier signal in far southern California and the wetter signal for the Pacific Northwest, but also near normal conditions for most of California, which would be beneficial for the drought. The official forecast calls for above normal temperatures across most of the Southwest. In fact, this has been a broken record over the past few years. Examples of how to interpret this forecast are shown on this map. This is for December through February winter outlook. Now, when we take a look at the precipitation outlook, we can see the signal is for the tendency to be below normal, or the odds are best for below normal. But also note that the odds are not far off from being above normal. So in other words, there's not a lot of confidence across California. And you can look at particular regions here and decipher what the statistical forecast information means based on everything we talked about prior in this presentation. Okay, a quick recap. 5 years of drought. It's the worst drought when you factor in how warm the temperatures have been. We've not seen a warmer period across Southern California or most of California. This also includes the winters. We have critically dry fuel moistures, critically dry soil conditions, and unusually low reservoir conditions. All this is a concern because Santa Ana winds occur in the fall, and actually they peak out in December. Santa Ana winds peak in December. On a normal year, we have rain by December, so it's not as much of a factor. Now, our El Niño or La Niña conditions are only part of the weather and climate. Please keep in mind that when we talk about La Niña and El Niño, it's an oceanic temperature condition. It's not an atmospheric condition, and it's not rain or snow or storms. We do expect weak La Niña ocean conditions for this upcoming winter, and the tendency is for drier than normal winters, but we've seen extreme weather events or extreme precipitation events that can make much of the weather season, and we've also seen those in these weak La Niña conditions. So that's something to keep in mind, and every year is good to prepare for the potential for excessive rainfall. Even if it's only a week of rainfall, it can be very high impact. Thanks for tuning into this latest report on the state of the climate and the outlook.